Alright guys, so today we are starting chapter 7, which deals with oblique triangles, meaning triangles don't have any right angles. And with that, we're starting with the law of sines, which is pretty much the most commonly used equation or formula for this chapter. So first of all, I'm taking a second to write down basically, as I was saying, what an oblique triangle is a triangle with no right angles. One thing that I'd like to point out that's pretty important for this chapter is when you're drawing these pictures of all the triangles, it's assumed that they're all going to be set up the same way. And that way is going to be that if you see anything that's a C, or here, a gamma or a C here, angle measure C will always be opposite side length C. Likewise, the B's will always be opposite of the B's, and all your A's are opposite of each other. And so whenever you're drawing the picture, it doesn't actually matter where you put any of the angle measures or side lengths, as long as angle A is opposite of side A, angle B is opposite of side B, angle C is opposite of side C, then you're in good shape. So here's the law of sines. Take a second, copy it down. Once you've done that, what you'll notice is that, well, there's three different things set equal to each other. The beauty of this is you don't have to use all three. You just need two. So like if I have an example, if I have a side length A and an angle A, and I need to find a C, I don't have to use this B ratio at all. I could just set this ratio equal to that one. Or let's say I don't have a C, so I don't have to use that. I would just use this ratio and this ratio instead. So it has a lot of flexibility, which makes it really useful. It's just probably why it's, one of the reasons why it's the most commonly used of these. So here what you have, basically in a nutshell, sine of an angle A over side length A equals sine of angle B over side length B equals sine of angle C over side length C. So in this case, one thing to keep in mind when we're solving oblique triangles, meaning we're finding all the missing parts and pieces, we need one side length and two other facts. And here there are three different cases. You'll recognize them from geometry. And the reason we talk about these cases is some people do a lot better just memorizing which cases to use what in. I'll also show you another way of figuring out whether you should use the law of sines or you should be using the law of cosines, which we get to later. So here's the first one. I said pause the video, write it down. Second one, if you pause the video and write it down. And here's the third one. Now this one you definitely need to make sure and put like an asterisk or something by, because this is the ambiguous case, as it's noted down here. This one we'll get more into specifically tomorrow, because there's some extra things that you have to check. But one thing, if you're looking at all these different cases, again, here's the first one. The shortcut to all this is to use the law of sines if you have a situation like this. If you have an angle and its opposite side length as given values, you're using the law of sines. So like here's the one for angle side case. Here, you're like, well, wait a second, Mr. O'Connor just said this should work. But what you'll notice is you're given that angle and that angle, and you subtract them from 180. So 180 minus angle, you'll get this, and then you'll have the angle and the opposite side length, which is what you need to use for the law of the sines. And lastly here, you'll notice you have a side length and the opposite angle measure. So the law of sines is what's being used again. So let's try this. So we're going to solve this completely. So first things first, let's draw an oblique triangle. Make sure I label your sides and your angles right away. So here I have angle A, B, and C. So I'm given that angle alpha, which is A, is 40 degrees. So here's 40. B is 60, so B is 60 degrees. And side length A is 4. So if you have this situation, what I would check for first, if I'm on the test or something, I have an opposite angle and side length, so I'm using the law of sines. So what's going to be easiest to find here? Well, the easiest thing to find probably is this angle measure C, because you have these two angles. So angle C, angle C is just going to come out to be 180 minus 60 minus 40. So let's find that. You should come up with 80. Okay? And let's see if we're right here. Yep, 80 degrees. So then next, we need to find, well, the only thing we're missing two parts. We're missing side length C and we're missing side length B. So let's find B first. So to find B, we're going to have the sine of 40 over side length A, which is 4. I picked that first because that's the given that are opposite of one another. So that's what we want to use. And then I want to find the sine of 60 over, I'm trying to find side length B. So that's kind of a goofy looking B. Where do you draw that? So over B. So then how do you solve something like this where you have fraction equal fraction? Now this is where you go back and you cross multiply. So you cross multiply, you get 4 times the sine of 60 equals B times the sine 40. We're then going to divide everything by the sine of 40. So you get 4 sine of 60 over the sine of 40 equals B, which plug in your calculator and you should end up with 5.4. So this is 5.4. So now, as you can see, we only have one thing on this triangle that we're missing, and that's side length C, so we're going to solve it next. Now, one thing I would recommend, since the 40 and the 4 are given, when you're using law of sines, keep using those in all the future equations you set up. Meaning, like, when I solve for side length C, I want to use the sine of 40 over 4 still. So then let's plug in the sine of 80 over C. You would cross multiply again. So we're cross multiplying. So you'll end up with C times the sine of 40 equals 4 times the sine of 80. And then divide by sine of 40, and you get C equals 4 times the sine of 80 over the sine of 40, which you would then plug in your calculator and hopefully you get 6.1. So now everything in the triangle is found, all 3 angle measures, all 3 side lengths, so we've completed this problem. So that's your first law of sines problem. Alright, let's look at this next one. So let's see here. We're going to draw our triangle again. A, B, and C. Alright, so then let's see. Alpha is 35 degrees. 35 degrees. Beta is 15. And C is 5. So in this example, what I'm looking for is side length and its opposite angle, which you can see we don't have yet. However, we have the other 2 angle measures, so we know that C should equal 180 degrees minus 35 minus 15, which plug in your calculator and you will get 130 degrees. So that's 130. So now we have the side length and its opposite angle measure. We can now use the law of sines to find the other values. And so what I'll do is I'll set up the 2 equations. I want you to try them out and let's see if you get the right answers. So you would start off with the sine of 130 over 5 equals the sine of 35 over side length A. That's one equation. And your other equation would be the sine of 1 30 over 5 equals the sine of 35. Oops, sine of 15. Sorry. Sine of 15 over side length b. So pause the video, try working those out. There are your two answers. See if you get those right. Hopefully that makes sense. Here's the homework. Like I said, you have the homework worksheet. It's due tomorrow, very beginning of class, at least the first 6 problems of it. If you want additional practices, or you want to check additional things, you can look at these problems in the book, and they're also similar to what we're doing. Hopefully this makes sense, and I'll see you guys later.